Good evening, everyone. Tonight is another of those special public forums at the Goodman Cancer Research Center. And every time I start those public forums, I start by the why. I explain why we do this. For those of you who know, who've heard about all the great science that's done at McGill, you probably felt it as well. There seems to be, I would say, difficulty in transmitting all this great science that is done in our gem that is McGill in Montreal. It seems to be always somewhat difficult to bring that cutting-edge science to people in our community who support McGill so well. And that is particularly important with cancer because for some of those recent advances in research can really affect the treatment decisions and can really affect the decisions that we make in our lives as to just as much in prevention as to what we do with treatment, for example. So part of the purpose of this forum is to bring the latest of research of science to the public. So we really owe you that, that's for sure. The other reason why we do those forums is to feature some of the best researchers we have, really world-leading researchers that we have at McGill. Sometimes it's collaboration initiatives that we have across departments. Some other times it's just wonderful researchers and clinicians that we have in McGill and in our sister institutes. And that's what we have tonight. I'm Thomas Duchesne, and I'll be your host tonight. I'm a professor at the Goodman Cancer Research Center and here in biochemistry. As a matter of fact, this is usually my teaching class. So I'm used to see graduate students looking at their laptop here while I present and texting and stuff like that. So. But we really have a great talent pool here, and I can tell you that they are really wonderful researchers as well in the lab. So they're the oxygen of this university. So I want to acknowledge all the great students we have here. Tonight, we have a wonderful program, and we'll take you from the clinic to the very basic research that is done on HPV. And it's going to be really important to cover all of this because in the case of human papillomavirus, research has taught us that we really have a handle on this virus in many levels. Whether is it immunization, whereas it's with papilloma, with a pap test, whereas it's new initiatives that discover new targets for HPV, but also other viruses. We really have here, what I see is a very powerful, multi-fronted approach on a virus where we actually can do something. And we'll hear first from Lucy Gilbert from the Department of Obstetrics and Gynecology and Department of Oncology here at McGill University. She's also director of the Gynecology Center Cancer Service at MUHC, at the Cedars Cancer Center. She will be covering all of the clinical implications and the consequence of HPV-related cancers in women. Then we'll hear a lot of the basic science and essentially the molecular underlying, the molecular events underlying HPV biology and essentially why is this virus leading to cancer? Why do certain viruses lead to cancer? How do they do that? And what does it mean essentially for therapy and for the disease progression and intervention? And finally, we'll hear from Eduardo Franco. Eduardo is James McGill Professor, Department of Oncology and Epidemiology and Biostatistics. He's also the Director of the Division of Cancer Epidemiology and chairman of the Department of Oncology here at McGill University. And Eduardo is also a very, very strong advocate for prevention and essentially a champion of bringing science to the clinic. We're really glad that both Lucy, who's spending so much time saving lives in her clinic also, and time is very, very precious in the case of Eduardo and Joe also, so we're really grateful that we have you tonight. So after those presentations, we'll have a testimony by someone very, very generous that I'll introduce a bit later, coming and telling us about her story, her life story, and how HPV and the diagnosis of cervical cancer affected her, and how she went through this, and how essentially science and research and teams around here at McGill impacted her progression through this disease. And finally, after you've sorted all of this and figured out what the best questions you had and written them down on a white cardboard, we'll have this traditional open question and answer sessions, about half an hour of just whatever's on your mind you can ask. So the way it will work at that point is you certainly have those white cardboards in your hand. At any point this evening, if you have a question in mind, just write it down. And after the testimony, Ivana will have runners capture those little white cardboards and bring them down here, and we'll just essentially have a question answer session. Keep in mind, though, that those questions have to be of general interest. You can be very curious. You can cover things that are way out there for as long as they relate to in general, and they're not really your own personal clinic or clinical concern. So we're not looking for personal stories here. We're looking more into questions of interest. If you have questions, you have concerns, you look for references for your own treatment, or you have concerns that you want to ask more in private, you're welcome to do so after the forum, around 8:30 or so, after the forum is done. So again, those questions, try to ask questions that are of general interest. All right, so the presentations will be in English, mais si vous avez des questions, vous avez des curiosités à poser, posez vos questions par écrit en français. Je vais traduire les questions. Puis s'il y a des questions dont la réponse est donnée en anglais, une question en français, je vous la traduire en temps réel. La plupart des présentateurs parlent en français ici, puis n'hésitez pas. C'est McGill en général, ce qui se fait ici est en anglais, mais tout peut être très facilement traduit. Gênez-vous pas à poser des questions en français si c'est le cas. Right? So, without further ado, we hear from Lucy Gilbert. And Lucy has a practice here at the Cedars Cancer Center. And she's also a leader in many ways, in everything that relates to human papillomavirus. Everything clinics, but also advocacy and education. So we're really grateful that you're here tonight, Lucy. Thank you.
Thank you so much, Thomas, for arranging this. I think it's very, very important to, as you said, that we convey and educate and inform people so that all the work we do translates into results. So I shall confine myself to the clinical things because I'm followed by two people, as Thomas said, who will talk about the science and the impact in global terms and in national terms. I'm going to start with a customary disclosure. I have no conflict of interest whatsoever. I did work on the HPV trials and so on and so forth, but absolutely no conflict of interest. But I do have a disclosure. That is, I love HPV-related cancers. Why am I crazy? I love it because doctors do not like to feel impotent. And with all the other cancers, I'm in the clinic feeling absolutely alternating between rage and sheer impotence because people ask me, what caused this cancer? Don't know. Will I be cured? Not really. We can delay things for a little while. And the way I treat ovarian cancer is almost exactly like I treated it 20 years ago. I'm 65 years old. I've been doing this for over 30 years. And what I do for the other ovarian and endometrial cancer has not changed much at all. And cervical cancer and vulval cancer, it's been transformed. And it's been transformed because of science. Here is one of the few instances. When I hear people say, oh, we're going to conquer cancer, we're going to do this, I think, no, we're not going to. Why? Because most cancers are just related to aging. And you can die of some infectious disease or tuberculosis earlier, or you can live longer and get cancer. And here is a cancer one of the few cancers, and Joe has a slide, one of the handful of cancers that's caused by one thing. And if you know the cause of something, then you're halfway there. And this is what transforms. So I'd like you to look at the picture of the cervix, the uterus, which sits, can you see so the uterus sits with the bladder in very close proximity and the rectum behind, and all these beautiful nerves and so on and so forth, very close near the cervix. But the top of the uterus is free, the ovaries are relatively free, and so on. So the average hysterectomy we can do with our eyes closed. I mean, we keep our eyes open, but we can do it with the eyes closed. However, cancer of the cervix is that it goes to the side, it goes to the bladder, it goes to the rectum, it goes to the side wall. So the surgery for cancer of the cervix, if you don't get it in time, is brutal and quite vicious. And it's a kind of surgery that in olden days, we would have to keep 4-6 units of blood in the OR and so on and so forth. And that has been transformed because of science. And this is the incidence that's been coming down and coming down. So now, in a civilized, humane country like Canada, there are more ovarian and endometrial cancers, deaths from ovarian and endometrial cancers in Montreal compared to cervical cancers in the whole of Canada. That is what science and research did for HPV-related cancer. The moment you know a cause, you can start working against it, and we will, Eduardo and Joe will cover some parts of it, but I will too. So this is why I absolutely and totally love HPV-related cancers. Now, the outline of my talk, I'll cover very briefly the clinical consequences. I will also emphasize on the most important thing, which is the early detection and prevention. Okay? And I think a lot of what Eduardo will say will relate to the prevention part. So the HPV-related associated cancers, obviously I will talk only about women, but I can mention what it does to men too briefly. I put 100%, that in medicine you're never allowed to say 100%. So 99% of cancers of the cervix are caused by HPV. The vast majority of cancers of the vulva nowadays are caused by HPV. In the past, and I came from the north of England, and there was a lot of mills and dyes used, and women sitting there. And, there was a lot of carcinogen-induced cancer of the vulva. It is related to another disease called lichen sclerosus, but those numbers are falling. And I see in the HPV-related vulval cancers incidence is going up. And the surgical treatment of cancer of the vulva is not nice at all. So this is why prevention is the key. So 90% of anal cancers are caused by HPV. And what you mustn't forget is the head and neck cancers, the oropharyngeal cancers, cancers of the base of the tongue, the pharynx, the larynx. HPV is a very important player in this, okay? So again, this is the picture of what one has to do if you get it while it's precancerous on the cervix. The treatment takes all of 5 minutes. Okay, ablate it, and it's over and done with. You follow up and so on. That is, and the other good thing about HPV-related cancer is it has a very long natural history. So you don't have to freak out just because you have an abnormal pap test. You have the time to address it, ablate it, so on and so forth. So if you keep seeing HPV-related cancers now, it's either the person has been unfortunate enough to be immunosuppressed, because a lot of the treatments nowadays use immunosuppression, so that is something we can't do much about, or the doctor messed up, or the patient didn't go for screening. So it's totally, other than the immunosuppressed category, this should not be happening, really. So, so if you don't get it at this stage, when it's confined to the cervix, where you can just scoop it off or buzz it off, you then end up with your big, huge surgical procedures. And this is the side wall of this is a woman looking forward. This is the side wall of the pelvis. It's rich in blood supply. These are the delicate nerves we have to disrupt, which affects sexual functioning, which affects bladder, which affects the rectal functioning, and take half the vagina. So this is, I hope I've made my point clear. It's a preventable cancer. You can, if you get it, see it very, very early in a thing, a very small surgery, and the longer and longer and longer you let it go, it becomes a big deal. So that brings me to my next thing, which is early detection. So early detection means you pick it up either when it's very small, it's already become an invasive cancer, or it is in a precancerous phase. Okay, and for that is where the screening comes in. And Canada was one of the first countries to invest in it, and you saw how the incidence of cervical cancer and the deaths have gone down steadily. It's beginning to go up a little bit, but then I believe Eduardo may touch upon it. But the pap test is one of the cheapest nothingness tests. Okay, it's taking something from the cervix and with a little wooden spatula and putting it on a slide and looking at it. And such a boring, ordinary test has made such a huge impact, because it gives you the chance to treat it when it's precancerous, even when it's very, very early, and then it's over and done with. And really, if you find cervix cancer now, and unfortunately we do, it's horrible. It affects young people. We have just lost a woman with a 3-year-old child because it's a cancer of young people. Okay, and you think, why didn't you? We have somebody who's a ballet dancer for a Canadian thing, and people are busy and they think, oh, we don't need this to be screened. And these are preventable cancers, and you need to be screened, and you need to take it seriously, okay? So what are the recommendations for screening? In the past, we used to be obsessional and start very, very early, because people tend to have sexual intercourse fairly early these days. However, there's very good, in everything you do in medicine, you must weigh the pros and the cons, and you do not start it too early. There's fairly good recommendation that you should start it at the age of 25, but you can do it from the age of 21 onwards, and you have your pap test regularly every 3 years. And after the age of 30, there's very good evidence to show that rather than pap test, you can have HPV testing, Before the age of 30, I'm not an advocate of doing HPV testing because of the fairly high false positive rates, and people get so distressed. People get very, very distressed by being told that they have HPV infection and so on and so forth, and they may clear it and there may be no consequences. But after the age of 30, it really is superior to cervical cytology, the standard pap test, and you can do it every 5 years. And if you have had regular pap tests, there's absolutely no advantage having a pap test after the age of 65. And now it comes to the final thing, which is prevention. Prevention is the key. If somebody told you you can prevent a cancer and you didn't act on it, it is really, really, I think it's a shame. And the prevention is using vaccinations. Okay? Now, how many minutes do I have? I can... 3 minutes. Okay. So this is what I would say. There are programs. We are lucky enough that there are immunization programs for introduced in school. Quebec has gone off on a limb and done its own little strategy, but it's almost a sin not to immunize against a disease that can wreak havoc in a human being. And it's not just cervical cancer. I spoke about women. It's for men, head and neck cancers. None of these cancers are fun, okay? And here is a preventive program. And I'll come back during the question and answer period to talk more about the vaccine and what is available and what else you can do, because then I'd like not to exceed my time. Okay, thank you.
Okay, good evening, everybody. So thank you to Tomas and for the other folks here at the GCRC for organizing these great public outreach events. My name is Joe Teodoro. I'm a virologist and a cancer researcher here at the Goodman Cancer Research Center, just right next door. And for a large part of my scientific career, I've been interested in how viruses cause cancer. And so you might want to consider, so what is it, when we think about viruses causing cancer, when we think about cancers worldwide, what percentage of cancers actually are attributable to viruses? And the answer to that question is a little, it might even seem a bit scary. And it's about 20% of all cancers in the entire world are caused by viruses. It's a bit of a scary thought, just to think that there's these agents floating out there in the environment that can lead to cancer. But for those of us who were working on cancer researchers and working on alleviating the burden of cancer in humanity, it's a great opportunity, because as Lucy said, we know exactly which viruses cause cancer, and if we can somehow control the behaviors of people to come into contact with these viruses, if you can come up with drugs and as we'll see, vaccines, we have 20% of cancers that we could potentially eliminate from the face of the planet. So when we talk about virus-induced cancer, we really have to break things down between men and women, because the profile of cancers in men and women of virus-caused cancers in men and women are very different. So here in this first slide, I'm just showing you what types of cancers are caused by viruses. So you see, in women, of course, the major cause of virus-induced cancers are cervical cancers. In men, it's a bit different. You see, it's actually liver cancer. So as we know, it's HPV that causes cervical cancer, but there are many other viruses that can potentially cause cancer. And in liver, we're talking here more about the hepatitis virus, hepatitis B, and hepatitis C. These are really big factors in causing cancer. It's a huge public health problem worldwide. Hepatitis C infects about 3% of the entire planet. and many of these people are then left with predisposition to liver cancer. So in women, you can see the liver, it's predominantly cervical cancer followed by liver cancer, and there are other types of cancers as well. Another big virus that causes cancer is Epstein-Barr virus, which causes mononucleosis. Some of you may have had that in the past, infectious mononucleosis. So, but our evening is centered here on HPV, and that's what we're going to focus the next little bit on. So I also just, before I talk to you a bit more about the virus, I want to show a couple of statistics that really show a unique aspect of cervical cancer. So in this pie chart you see here, it shows the mortality from different cancer types. And this is actually focused just on high-income countries, just women, and a breakdown by mortality by each type of cancer. And you can see in Canada it would look very much like this. Lung cancer is the biggest killer of women, followed by breast cancer. And so if you look, where is cervical cancer on this pie chart, you have to actually go all the way around. It's in orange all the way around here. It is actually the 13th ranked killer of cancer-related deaths in women. So this is in high-income countries. Now what happens if we do the next pie chart I'm going to show you is the same statistics except in low-income countries. And I want you to keep your eye here on the orange piece of the pie here and see where it goes. And there you go. So in low-income countries, it is the biggest cancer-related killer of women. And this really highlights two really important points about cervical cancer. One of them is that without proper screening and treatment, this is one of the biggest cancer killers out there. It's very, very aggressive cancer. And the other major point I want to make with this statistic is it's almost completely preventable. So in high-income countries where you have access to screening and to treatment, it goes from the biggest killer all the way down to the 13th biggest killer in cancer-related deaths. So, as Lucy mentioned, the cause of virtually every cervical cancer is HPV. And I also put 99% here. As a scientist, we never like to say everything's 100%, but it is, it is virtually every single cervical cancer, pretty much, that is caused by HPV. And this is the strongest association we have between a cause of cancer and a cancer itself, is this link. It's 99%. Another, if you think about, say, cigarette smoking and lung cancer, about 90% of people who come down with lung cancer were smokers. So the association with HPV and cervical cancer is even higher. How do we know that? What makes us so certain that this virus causes cervical cancer? So there's a few things. Some of these have been known for a long time. So cervical cancer, if you look at sort of the pattern of how it happens and the people who get it, it's always followed sort of the general pattern of a sexually transmitted infection. So you have people who abstain from sex. The incidence of cervical cancer is very low. On the other end of the spectrum, people say sex workers have a very high incidence. So they follows that general pattern that is a sexually transmitted infection that causes this. And sort of in more modern times, and maybe not so, in the 1980s is where a lot of really key HPV research took place. And what started to be found was that when you start to look at these tumors, that you can find pieces of the DNA from this virus that are integrated into these tumors. And virtually every single cervical cancer has pieces of HPV in it, and I'll get a bit more into that later. And it was this work that really broke open the whole cause and it cemented the link between HPV and cancer. And it was such a momentous collection of research. It was actually spearheaded by this gentleman here, Harold Zerhausen, who in 2008 was actually awarded the Nobel Prize. And he was it was his work. Worked in Heidelberg, who really found the link and found the sequences of HPV in these different cancers, and it was such a momentous set of work. He was given the Nobel Prize for this work. Another person I want to highlight was only now more recently being feted is this lady here, Henrietta Lacks. So Henrietta Lacks was a housewife, an African-American housewife who died from a very aggressive cervical cancer in the 1950s in Baltimore at Johns Hopkins. At that time, scientists were really struggling to try and get cells from humans growing in petri dish, growing in culture. And it was a huge struggle to get this done. But at that time, it was a researcher at Johns Hopkins took a specimen from her cancer and tried to grow it in culture, and it just took off. And that highlights sort of the aggressive nature of this cancer. The cells here are just so, they grow immensely quickly in these cells. We grow these cells in the lab all the time, and they grow so fast, and they just, it's incredible to watch them. And her cells have gone on to also be instrumental in the research of HPV. Harold Zerhausen actually sequenced and found the HPV genome in her cells, which are not, they're called HeLa cells after her name, Henrietta Lacks. They've been instrumental in so many others, in also making the polio vaccine and many other key discoveries in science. And this all started from these cells, from this cervical cancer, from this lady, Henrietta Lacks. And her story was recently, it was a very great book. If anyone's interested in following her story, The Immortal Life of Henrietta Lacks, a book by Rebecca Skloot, and also a movie starring Oprah Winfrey, if you don't have the patience to sit through the book. So what is HPV? Well, let's take a step back for this. So what is a virus? HPV is a virus. So what is a virus? Everybody has sort of idea what a virus is. Here we have sort of cartoons of viruses, and they're all drawn to scale of different viruses that are known to cause diseases in human beings. And you can see they come in all shapes and sizes. Here, this big, huge monster here. You can see this is an Ebola virus, which is often in the headlines. You see it causing these hemorrhagic fevers in Africa. You got this other monster up here, which is pox virus, variola virus, which causes smallpox, which has thankfully been eradicated from the face of the planet using a vaccine. And the topic of this evening is down here, papillomavirus. That's a small little guy down here. So even though viruses all come in these different shapes and sizes, they all have really some common features. First of all, they're all incredibly small. You can never see these things with the human eye. You cannot even see them under a microscope. In fact, in order to see them, you would have to put them under a very powerful microscope called an electron microscope. Another property that all these viruses share is that they have only one reason for existence, and they do only one thing, is that they make more copies of themselves. That's what they do. That's all a virus really aims to do. And the third thing that viruses all share is that they're parasites. They cannot do anything. The only way they can make copies of themselves is by entering one of our cells, and that's where they make copies of themselves. If they're sitting outside, they have this dual life. They'd be inside the cell, they'd be outside the cell. But outside the cell, they're just sort of a collection of chemicals. And I teach fundamental virology here at McGill, and students often come and ask, are these things alive? And it's sort of a philosophical question, because outside they're just a collection of chemicals. They're not really alive. But once they enter the cell, they come to life. They change the entire biochemistry of the cell and just gear it up to make more copies of themselves. So this is what HPV is. It is a virus. And here, if we zoom in further on, this is one of those electron micrographs I was telling you about. I find these things beautiful. They have this beautiful symmetry to them. And that's what we're seeing here is a cryo-electron micrograph of a papillomavirus. And what we're seeing here, this is a protein capsid, a shell. We call it a capsid in virology. And it's hollow. And this thing is this protective protein shell. And inside is the genome, the DNA of the virus. And the virus we have about 25,000 genes. The virus has only 8 genes. And it has the instructions to do one thing, and that to make more copies of the virus. So when we talk about HPV, it sounds like, HPV is one thing. But actually, HPV is not one thing. It's a big, big family of viruses. In fact, we're up to about 150 different human papillomaviruses that are known to infect humans. It's a huge family. And this is sort of what you see up here is a kind of a family tree of the different HPVs. And so the ones that are on these branches tend to be more related. And some of them are quite innocuous. So, and the viruses, the HPV viruses, what they are viruses of the skin. That's basically where they hang out, that's where they replicate, that's where they live. And everything that they cause happens in the skin. So you have things here, so in green here, one of the things that HPV causes, and these are some of the ones that are a bit more harmless, is they cause warts. So on the tips of your fingers sometimes, you get these little growths. And what a wart is essentially is a small benign tumor. It is in fact an aberrant growth of cells, like a tumor, except it's not malignant. It won't spread and kill you. The immune system will eventually swarm over it and get rid of it and clear it. So, and these are incredibly common. These viruses are everywhere. There's also other ones that cause, like verruca vulgaris, similar thing except on the soles of your feet. And also warts on this. But you see now here in red, you have these other types of HPVs that actually cause genital warts. And we have these high-risk ones. And the main ones that are type 16 and 18, and about these collectively cause about 70% of the cervical cancers. So all I have to say, HPV is not, it's everywhere. And probably all of you have some HPV somewhere on your skin right now. And it doesn't always cause disease. But of the high-risk one, the high-risk cervical cancers, those are the ones that cause all the trouble. And the clinical progression of HPV looks something like this, and even infections with HPV are incredibly common. So the statistics here I'm showing there, in the US here, there's about 10 million cases every year of women who have come down with infections of HPV. And most of these lead nowhere. It's just that what happens is there's an infection, the virus makes more copies of itself, and then the immune system eventually just clears it, and the woman will never have any more problem from this cancer, from this virus again. In about 10 to 20% of the cases, though, it can go on where the virus sort of persists for long. This can happen to persist for even up to a year, where there's virus being made. But eventually, in most of these cases, again, the immune system can just clear the virus, and they never had any problem for it. So you can see, so from 10 million cases down to about 2 million cases that might go on to a more persistent viral infection. So some of these can go on a bit further, however, where you can now get a more of a growth now here in the cervix. Here's where we got about 300,000 of these. And the last stage here, we go from 10 million infections down to 11,000 cases in the US, where you actually get a full-blown cervical carcinoma. So a couple things I want to really point out, though. These infections, the time between the initial infection and the final full-blown cancer takes years to decades. So a woman who may come down with cervical cancer in her 40s or 50s, she might have been exposed to this virus in her 20s. It can take quite a bit of time for this to happen. There's also there's leading here to this point where you get cancer, the cells are also probably acquiring other mutations in them as well in order to reach this really invasive cancer state. And as Lucy was leading to this, what you look for, the screening, this is really the differentiation. So why in poor countries, so many women are dying from this, whereas in high-income countries, we can save so many. And it all comes down to being able to detect as early as possible here with the Pap test, these early lesions, which can be treated very early on. And the Pap test is really is what has brought the incidence of the cancer down to the levels that you see the difference between the low-income and high-income countries. And this was introduced in the 1950s, and the Pap test does not stand for papilloma. It actually stands for this gentleman's name here, George Papanicolaou, and he was the one who came up with the first idea for screening. And as Lucy said, it's a very simple thing. You just take a little sample from the surface of the cervix, you put it on a microscope slide, and essentially what you're looking for is aberrant-looking cells. You see here, this is sort of a dramatic example of a Pap smear with an abnormal cells. You're not supposed to see these cells with large nuclei. You should not see these at all. This is what a normal sort of skin cell looks like. It has a tiny little nucleus, and if you see these cells with big nuclei, there's something wrong here in this person would be flagged for further follow-up with a doctor. This test really has really been instrumental over the last few years, in the last decades, in reducing the burden of cervical cancer. So how is the virus actually causing cancer? You know, that's been one of the questions that I've really been focused on. And you know, as I mentioned, the DNA of the HPV is left behind in the cells, in the cervical cells, the epithelial cells. And this is in some of the work from Harold Zerhausen when he was looking to see, well, you know, which pieces of the genome, because it's not always the entire genome that's left behind, it's small pieces of the viral genome that's left behind in the cells. And what they initially found is, you know, what is the minimum rate? What are the genes that actually need to be there? And these are the 8 genes that we know are in the HPV genome. And there's actually only 2 genes that are always maintained in the cancer cells. And there's these 2 genes, one called E6 and one is called E7. So what do these genes do? So this is what a typical, so this is what the Henrietta Lacks insertion into her cells, into the HeLa cells look like. You have the E6, E7 gene from the HPV virus inserted into one of her chromosomes, and then it makes messenger RNA, which leads to the formation of the 2 proteins, E6 and E7. And what they do is they bind to 2 proteins, cell proteins in the cell. One of them is called P53, and the other one is called RB. So what are these things? So let's start with RB. RB means retinoblastoma, and it is a key tumor suppressor protein in humans. And that's where the name comes from, actually, because families which have mutations in the retinoblastoma gene have predisposition to this type of cancer, an eye cancer called retinoblastoma. And what RB does is when you have cells dividing, you know, they have to replicate their DNA. You do DNA replication. And what RB does is it blocks DNA replication. So in non-dividing cells, RB is a brake, and it prevents cells from replicating. So that's the main function for RB, and the virus inactivates this protein. The E7 protein comes in, binds to RB, and takes it away. So it can't do what it wants to do. The other protein here is P53. So P53 plays an even more important function. So this protein exists in lots of different, in humans for the sole purpose of preventing us from getting cancer. This is the major tumor suppressor in our bodies. And what it does is it gets turned on by things that cause cancer. It gets turned on by viral infections. It gets turned on by radiation. And what it does is it responds to these insults by killing cells. It induces what we call programmed cell death or apoptosis. So it gets rid of compromised cells before they can become tumors. And there are families also with mutations in P53, and these people are incredibly susceptible to cancer. Some of these people come down with 4 or 5 different tumors in their lifetime and usually die young from cancers. It's there, this thing is there to prevent us from getting cancer. The virus binds to this and inactivates it. That's what's going on here with E6. It binds up to P53. So the question is, why would a virus want to do these things? Why would a virus need to inactivate these things and cause cancer? And the answer to this is relatively simple. Remember, the virus, the only sole thing it wants to do is to make more copies of itself. The problem is, the cells that it's infecting, like most cells in our body, are not dividing. They're just sitting there, they're doing what they need. They're being skin cells, they're being heart cells, they're being brain cells, whatever. The virus infects them, but it now faces a problem. It wants to make more copies of itself, which means it needs to make its copies of its DNA. Cells that are not dividing are not making DNA. So what does the virus do? It makes these proteins that force the cell to make DNA, which means what it's doing is it's forcing the cells to undergo the cell cycle, which is what you see in tumor cells as well. So that's why HPV is doing this. It's not trying it doesn't have a vendetta against humans. It's just trying to make more copies of itself, and that's what it's evolved to do. So finally, I'm not going to dwell too much on this. We're going to go back to the beginning. Remember, we have here, we know exactly what causes cervical cancer, and this is a great opportunity, because if we can just find ways to limit the exposure, and also to, if we can have vaccines against this, we can potentially eliminate this cancer from the planet. And this is ongoing, and Dr. Franco will tell you more about this. The HPV vaccine is now getting widespread. And I just want to show, so what's in the HPV vaccine, if you look at it underneath an electron microscope, it looks very much just like a virus particle, and that's exactly what it is. So it is a virus, except, you remember I showed you instead of having the shell with the genome inside of it, it's empty. So it's basically just a virus particle with no genome inside. The instructions to make new virus proteins are missing. So you inject this into people, they can mount an immune response to it, but the virus does not have its instructions there. So this makes a very nice immunogen against the virus. But I'll leave the further work description to Eduardo. So with that, thank you very much, and I'll be happy to take any questions.
Thank you very much. It's such a terrific opportunity to be here, and in some respects to give back to the community, as Lucy mentioned. It's such an honor for Lucy, for Jose, and for myself, and to give back to this community, this home, McGill University, which has been so accommodating to all of us in allowing us and permitting, giving us the ethos, the conditions for us to conduct the research that we're now showing you, and some of the results, in fact, that translating. And it's so true, what Lucy said in the beginning. It is one of the, talk about anything about cancer research. This is by far one of the most exciting stories that are out there. So let me, just a top view outline of what I'm going to get to it. And in fact, you're going to find that I'll be repeating a lot of the points that Lucy and Jose did, and I'll just try to give a different angle on the whole story, but it is important that we revisit some of these points. And there's a lot of history into this, because how did we get to this point? It's very important. So I'll show you some milestones in research, cancer research in general, on HPV, and which came from all walks of life. From basic bench science research in the laboratory all the way to public health research, health economics, all of those things that we do at McGill, in fact. And we do have now, and I'm going to be talking about those two, again, because you already heard from Lucy and from Jose that we have these two utilities that are absolutely tremendous and will give us the solution to the problem, and ultimately to eliminate. First time. We don't use the word eradicate. We're using carefully, cautiously the word eliminate one human cancer, which is cervical cancer. So we have HPV vaccination and molecular testing for HPV, molecular test for HPV, ultimately to replace this thing that we thought was working quite well, which is the Pap test. And I'll show you why we can do even better with molecular HPV testing. As you saw a picture of George Nicholas Papanikolaou, which is invented the test. That's a 70-year-old tool, the first cancer test ever done. And then I'm going to show you what we're going to be doing with these utilities. The World Health Organization has announced something very exciting, and what is Canada doing towards that direction. So let me do a little bit of pretend that I'm Jose Teodoro, and I'm going to do a little bit of the basic science of all of this. So he showed you the virus, right? Remember, 60 nanometers, 55, give or take 5 nanometers. And this is the virion, a single virus is a virion here. So keeping things in perspective, just to give you an idea how tiny these things are. So you know what circulates in our blood, right? In our vessels, red blood cells, and they're tiny as well. As you know, here's a red blood cell, which is 5,000 nanometers. Can you see that little greenish speck sitting on top of the red cell? It's right here, right? Can you see it? You can't see it. Those sitting in the back cannot see that. Now let's put that in perspective of a strand of human hair, and that's it. So this is the red cell sitting. Can you see that little red spot here, that little speck there? That's a strand of human hair. So this shows you how tiny this thing is. And now, imagine, this thing is an internal intracellular parasite, not only intracellular, it's an intranuclear parasite in many respects. So all of these discoveries, and eventually which are now with us for some 50 years now, as we understand more and more. And I'm going to give you a little timeline of how we got to this point. And when I say we, I mean we, our folks here at McGill, our folks elsewhere in Canada, all over the world, and primarily with our hero, which is Harold Zurhausen. You already saw a picture of Harold Zurhausen, who eventually went on to receive the Nobel Prize. Bear with me. So what you have here is a double graph, which shows the scientific productivity. Every paper, scientific paper published in the literature from the mid-70s all the way to present day. And what you see in blue, just the sheer number of papers published, which is the blue side, number of articles published, and we can actually count that, and we're available at the library. You can do that. You can actually go on PubMed, which eventually is the site which accommodates all of that, and you can actually see these papers. So this is the entire production since 1975 on human papillomavirus research in general, every possible aspect of the virus, molecular biology all the way to health economics, vaccines, everything, you name it. But you might say, well, there's tremendous growth here, right? I mean, the blue curve is really going up. From the mid-70s, when I started my career in the mid-80s, I could read every paper out there on HPV. And I was pretty much on top of my field. Can José Teodoro read every paper in his field? Impossible. Look at where we are right now, this explosion in the literature of science on HPV. But you could say, well, this is true for everything, right? Biomedical science in general. So let's divide the number of, which is the red side here, which would be the red curve. So let's see if it is truly a growth on research on HPV or just growth because everything in biomedical research has grown. And actually, when you look at the rate per 1,000 articles published in the biomedical field, there is a growth here. As you can see, it went from a little less than 0.5 per 1,000 all the way to what is today some 3 per 1,000 articles. 0.3% of the whole literature, biomedical literature, is on HPV research. And a lot of that has Quebec in it. And not necessarily McGill, but back here, this is 1976, HPV cytopathic effects in cervical cells. Remember that little cell that he showed with the virus replicating? You know, that caused some cytopathic effect, and it's called coilocytosis. And it was a Quebecer, Alejandro Maisels. He passed away, unfortunately. He was a professor at Université Laval in Quebec City who was the first one who actually discovered that. And he connected the dots. He said, well, wait a minute, I'm seeing in cervical cancer the same sort of elements that I see also in warts. Remember, he showed the tree with warts and all of that. So it's all coming from the same natural history of viruses, the same family of viruses that were there. So this was noticed by people like Zurhausen and others. And here's the first findings on HPV and 16. I can't quite put my pointer there, but hopefully you can see the second rectangle there, HPV 16 and 18, which are the most carcinogenic types of HPV. They were discovered and sequenced in Harold Zurhausen's lab by himself and as well as a number of scientists in the team. And things were evolving, as you can see there. Additional papers published on D6, C7, and in D5, more or less around the mid-80s. And that was the point where you see this thing here, the first and second IARC meetings on HPV. What is the IARC? IARC is the International Agency for Research on Cancer. So they called the very first meeting saying, hey, wait a minute. I mean, this thing that Dr. Harold Zurhausen discovered and some others are saying that's potentially carcinogenic, are they truly carcinogenic? Can we act on it? Can we actually eventually start doing things such as developing vaccines about that? And that it was not, the evidence was strong at that point, but it was not completely convincing. There were a number of I's to be dotted and T's to be crossed. And eventually by 1995, which is right here, I called again the experts, and they said, well, have you gotten your act together at this point? And they said, yes. And at this point, HPV 16 and 18, 1995, were declared official carcinogens, such as tobacco smoking, such as asbestos, and all of those things that you don't want to be close to. So at that point, 1995, and interestingly enough, happened in Quebec City when we had the papillomavirus conference hosted in Quebec City, and Merck And SmithKline Beecham eventually called the expert and said, well, now you got your act together. Should we invest on developing vaccines to prevent HPV infection? And we said yes. And in fact, I was at the meeting at the time. So 1995, Merck started, and eventually SmithKline Beecham started in 1997. And that was when the two humongous companies, as SmithKline Beecham eventually was bought by Glaxo later on, and they invested the $1.5 billion that eventually led to the three vaccines that we have today and that work so well. No public sector money. CIHR, the Canadian Institute for Health Research, NIH in the United States, the Gates Foundation, you name it. You think about any major funding agency in the world would not have the wallet to be able to fund this sort of research, clinical and research development. And things moved on in that same direction, development of HPV testing and clinical practice. In 2002 was the very first prototype vaccine tested. It was published in New England Journal of Medicine, very exciting, and it was 100% effective against HPV-16, the most carcinogenic of all types. In 2004 was the second paper published in The Lancet, and it was on the bivalent vaccine. And then in 2005 was the quadrivalent vaccine. And then, of course, I mean, from that point onwards, in 2006, June of 2006 to be precise, FDA approved these vaccines, and Canada, the National Advisory Committee on Immunizations right here in Ottawa, approved in December of 2006 these vaccines for public delivery. So that validation, remember, Zurhausen discovered all of these things in the early 80s. And because of vaccines are so effective and proven to actually interrupt the process from HPV infection to cervical precancerous lesions, eventually that validated, and the Nobel Prize in Physiology or Medicine was given to Nobel. Later on came a 9-valent HPV vaccine, which is even better. It's now available here in Quebec. Your daughters, your granddaughters are being vaccinated as we speak here in the program. It just passed because it was in September, so at the end of fall. And now we're going towards 2020, where we have truly a new horizon, which is the elimination of cervical cancer. And here's Dr. Harold Zurhausen. You saw a younger picture of Harold Zurhausen early on, and now this is him in 2008 receiving the Nobel. So I'm not going to repeat and I'm glad that Lucy went to the details about how this disease happens. I mean, it's an embarrassment of riches. The whole thing happens in a ring of cells that we can actually observe via colposcope. We can poke and take samples and follow up over time. And this helps a great deal, right? I mean, it's different than following up pancreatic cancer, which is inside. It's a visceral cancer, and we cannot quite follow the natural history. We can with HPV. We've been doing these things since the 60s. And in reality, so when you look at, and Jose had more or less a similar cartoon like that. So you have from normal cervix, and this of course is not at all in scale because you saw what the scale was a minute ago. So HPV invades the normal cervix, invades these cells. You saw the mechanism, how it happens with Jose Teodoros. Most of these infections eventually clear. That's the good news. We have conducted studies here with McGill University students, Concord University students. We have followed very closely the natural history of these infections. But eventually a few of those, 10 to 20%, as you heard before, eventually will progress and cause those abnormalities in the cells, and those are precancerous lesions. And still good, because we can actually catch them, and eventually the actual diagnostic, the biopsy, in fact, and many times cure that little tiny lesion that's there. But if time passes, as you can see, here's the timeline, eventually, if that breaks the basement membrane and eventually invades, that's the point of no return, then we start calling it cancer. It's no longer a precancerous lesion. But as you can see, we have a great opportunity to intervene. You know, we have been intervening for 70 years. As soon as these things appear in Pap tests, these abnormalities, we can actually trigger all the action Dr. Lucie Gilbert does so well, and eventually stops, arrests this development, and prevents cancer from happening. Better yet, I mean, if we vaccinate, we go even further upstream in the natural history and prevent the abnormalities starting from the first place by immunizing a woman against HPV. So multiple opportunities. And the secondary prevention, you heard this term before, because we're acting already after things happen. With primary prevention, we will act before things happen. And the end result of this is cancer. And how does that happen throughout the world? And you saw some slides about how common it is, and I liked the slide about death, separating the developing countries and the high-income countries from low-income countries. And you can appreciate, and this slide is a reinforcement of that same notion, the fact that we are here in Canada sitting quite comfortably with a very low incidence, because we have spent a bundle of money, and in fact, Canada has been one of the pioneers in implementing PAP cytology since the late 50s. And we have done so well. We do it in organized fashion. You know our healthcare system here. Don't joke. It's a very important thing. And it makes a big difference. So we enjoy here in Canada one of the lowest incidence rates of cervical cancer in the world, even better than the US, as you can see. Look where the disease is, the dark blue shades. Sub-Saharan Africa, Southeast Asia. Those are the poor countries that you saw, and that's where eventually most of the high mortality happens. So cervical cancer is, in fact, a sentinel of inequity in the world. And so all the actions we're doing here in Canada, in a way, we're playing good citizens to the world by developing these things and helping the world. But it's not only cervical cancer, it's not only women. It's also it's an equal opportunity disease, as you heard before. So when you look in Canada here, and this pie chart here shows in dotted you have men, and in solid color you have for women. So cervical cancer is a big chunk of the whole story. And in fact, we do talk about cervical cancer because for cervical cancer, HPV is a necessary cause. It's the first necessary cause of human cancer to be ever discovered. And that realization happened in 1999. We don't have anything else like that. Can you have lung cancer without ever smoking? Yes, you can. You can ask that same question for everything, except for this. Can you get cervical cancer without HPV? No, we can't. That 99% that you saw in both talks before actually is 99.7%. So it's at 0.3%. So for all practical purposes, we say that all of them are caused by HPV. It's like saying that all swans are white. And then the day that you find a black swan, okay, there you go. So it's not that all swans are white, but the vast, vast, vast majority of all swans are white for the purposes of prevention. And what are the tools we have to actually act in preventing all of this? Look at a collection of cancers that we have here. And of course, the most important one, the one that's going to have the most impact, and it has already started because we adopted those in Canada in 2008. Here in Quebec, Quebec was one of the pioneers. I'm going to summarize in this slide about 1,000 articles published on HPV vaccines. So these are facts. These are unassailable facts about HPV vaccines. Scientifically proven to be effective in multiple randomized controlled trials throughout the world. I said $1.5 billion. These are hundreds of thousands of women enrolled in these randomized controlled trials, extremely rigorous and in terms of regulatory oversight that they had. Highly efficacious. This was a big surprise. I was part of the advisory boards for these trials, and we expected 50% efficacy, and we would be happy with that. It was 95%. 95% efficacy to prevent infection with the target strains. You saw the examples of that little tree that Dr. Teodoro showed you. And with the target strains and their associated lesions. Right now we have a multivalent vaccine, a 9-valent vaccine, of which 7 of these strains cause cancer. And they're included, and they're being delivered here in Quebec and in all the Canadian provinces, including for boys, our boys here in Quebec. And they cover 90% of all cervical cancers. So that's the first hint that we cannot say eradicate, because there will be 10% of these cancers that will be left caused by these strains other that are targeted by the vaccine. But we'll deal with them when the research matures and to that point. Since these trials began in the mid-90s and they were followed, we already have observed enough of the protection. The course of vaccination of 3 doses, or nowadays 2 doses, will protect a woman and eventually a boy for at least 15 years. We don't know more because just time hasn't gotten beyond that, but likely it will be much longer because the antibody titers in these studies show that the protection continues. And we're lucky here in Canada to be one of the early adopters. Say what you want to say about the Harper government, but he actually jump-started the vaccination program in Canada with a $300 million grant to the provinces, and that helped the Canadian provinces to get started. So we were a little later than Australia. Australia was a true pioneer in doing that. The US did in their usual fashion, not organized as we did here in Canada by deploying this as part of the school-based vaccination program. So we did more like Denmark or the UK is doing, such as an organized universal vaccination to girls of the target age. We're already seeing the benefit. So there is already a reduction in the instance of precancerous lesions. And soon enough, I have a master's student working on this. Soon enough, we're going to see an understanding of a reduction on invasive cancer incidence. And what many people worry about is this vaccine safe? It is safe. By God, it's safe. It's one of the most thoroughly examined vaccines. It's a vaccine that prevents a sexually transmitted infection. So there's not only the scrutiny of the concern that it's a vaccine, but also because it prevents a sexually transmitted disease. Over 200 million doses have already been given throughout the world, and the safety profile is just comparable to any of the best things that you have out there. And this is one tool, the best one we can have right now, and we are already deploying. There's the other two. Okay, the ones that we cannot prevent, but at least let's see if we can do the secondary prevention part, lesions that have already started. For the women who are a little older, for instance, you saw the age, the guidelines that Dr. Gilbert showed you. We have molecular HPV testing. And this graph here illustrates, gives a summary of why it's so much better than Pap tests. We're happy with Pap tests. It has done a great job, but we can do better. We're in the science of 2019. So this graph, bear with me here. You have 1, 2, 3, 4, 5, 6 different studies, which the authors, the first authors are in the bottom. And you have the little n is the number of patients studied in each one of those studies. The Maran study happens to be ours. This is a McGill study that we conducted here. Maran was my PhD student. We published that in the New England Journal of Medicine. So this is, for every one of these studies, the light blue square indicates the sensitivity to detect precancerous lesions in these studies. What is sensitivity? Sensitivity is the ability of the test, in this case Pap cytology, to properly diagnose the presence of disease. So what's the proportion of those with disease that the test will get it right? In other words, positive, right? So that's sensitivity. So look at the numbers here. So this is the scale, sensitivity. Look at what we found here. This is Dr. Kulasingan. She's now at the University of Minnesota. We found in our study 55%. You folks have right now in your pockets and your purses a test that you would give that same sensitivity. So if you have 100 women with precancerous lesion passing through the door and you flip a coin, you get 50% of them right? You would say, well, if the head is positive, tails is negative. Well, that's not good, right? I mean, if a test that we're spending so much money eventually behaves as a coin flip, it's not that good. The good thing about the Pap test, which I'm not going to show you, is the high specificity, because a coin will also have false positives. If 100 women without cancer eventually come through your door and you flip a coin, it's going to be half of them are going to be positive, and that they are free of cancer. The Pap test has 98% specificity. In other words, only 2% false positive. So that's good. That's the reason we have been tolerating the Pap test for so long. And we compensated the sensitivity that's so low by doing it frequently enough. And by doing it frequently enough, if you miss it 1 year, maybe next year we'll detect the lesion. Enter the molecular HPV test. So why not detect the very thing that's causing that disease in the first place by calibrating properly? And you can see in the dark blue in each one of these studies, which is the performance of the HPV test in each one. Notice how constant it is. You know, they go up and down depending on the setting, but at the end there's an average difference of 36%. So it's 36% more sensitive to detect disease than our 70-year-old Pap test. So the idea is eventually to replace the Pap test or to augment the Pap test to make it better and to get to the things that we actually need to do, which is what I'm going to show you next, which is what the World Health Organization said. Hey, wait a minute. And this takes political courage, right? Because we're vaccinating in Canada. We're doing that in most rich countries, Western Europe, the US. But then eventually the highest office at the World Health Organization realized in 2018, we need to be a little more aggressive than that, because rich countries are doing well, they're implementing all of these tools, but what about the rest of the world? Look at this powerful statement by Dr. Nano Similela, Assistant Director General in the WHO. Elimination of cervical cancer is a global health issue within reach for all countries. We know what works. I just showed you the two utilities that work. And we know how to prevent and control this disease. So let's act on it. So this is of late 2018, a lot of agencies, countries, they had paid more than lip service to this statement, including Canada as well. And of course, one of these utilities was very expensive in the beginning. When we began to vaccinate, the cost of an HPV vaccine was about $300 a full course of vaccination in 2008, exactly when Quebec started its program. And eventually, with time, production, mass distribution, the economies of scale, and all of that, now 2014 is now, for all practical purposes, because that's the price that we have available. World Health Organization recommended 2 doses. And for $10, a total delivery, a total vaccination schedule. Now, why 2 doses and not 3? Because of Quebec. Quebec, in fact, in 2008, thanks to Dr. Bernard Duval from the Institut National de Santé Publique here in Quebec, and he passed away, unfortunately, a great hero. He never saw the end result of his experiment. Quebec decided, instead of vaccinating girls here in Quebec at age 12 and 13, 9 and 10th grades, they're already teenagers, let's vaccinate a little earlier. Let's vaccinate 4th and 5th grade girls in Quebec, and instead of vaccinating 0, 2, and 6 months, we're going to vaccinate 0, 6, and 5 years, 60 months. And in case protection happens and works well with just 2 doses, we'll suspend the 3rd dose. And he believed firmly that this was going to work because it worked with hepatitis B, and he said, why not? So Quebec, distinct society as we are, eventually worked, and it worked. Now the world does exactly as Quebec does, and now 2 doses have been recommended by WHO, thanks mostly to the early results that we had here in Quebec. So the cost of HPV vaccination has lowered tremendously. Now, as of 20 days ago, I got this slide from Dr. Paul Bloom from WHO. Half of all countries in the world have already deployed HPV vaccination in their national immunization program with some sort of financial assistance. Sounds impressive, doesn't it? I mean, it's going fast. But again, if you look at which countries, they're the rich countries mostly. We do have in the Americas, we're missing Venezuela. The state of situation in Venezuela. We're missing a few other places. But look at Western Europe, all green. We have Sub-Saharan Africa. We're missing lots of places. We have Australia, of course. They were the pioneer. We have Japan, and keep in mind, Japan is in green because I'm going to go back to Japan later. But when you look at the overall distribution of vaccines, we're really in deficit. So this shows for different countries in the world, this is from the poorest all the way to the richest to the poorest countries in the world, eventually the proportion of the population that's actually covered by HPV vaccination. So we need to do way more than simply allowing passively the national immunization programs to deliver their goods. So WHO stepped in with a plan, a strategic plan. This is called Global Strategy Towards the Elimination of Cervical Cancer. And with the following goals. The idea is to have a world without cervical cancer. It's going to take decades to get there, but we need to get started in 2020, implement all the way to 2030 all of these policies so that eventually we'll reap the benefits. And that's how we'll do that, by vaccinating 90% of all girls with an HPV vaccine and screening 70% of all women at least 2 points in life with a high quality test such as the HPV test. And for those lesions that are discovered by screening, 90% of them would have to be treated. So with this particular strategy, it has been very sophisticated modeling, and eventually that's the hope that it is. So the idea is to reach a threshold where all countries will be below 4 cases per 100,000. How tough is that to happen? Not too bad for Canada because we're about 7 to reduce to 4 per 100,000. We would be getting there in a few years just with our current vaccination program. So this very busy graph, I don't know if you can read it, but there are little cuts throughout these lines which shows regions in the world, and each one of these cuts are countries in these regions. Most of the world is over 4 per 100,000. And if you look at North America, where's North America here? You can quite see there. There you go. So the green cut is Canada. We're very close to the 4 per 100,000, and we're going to get there very quickly. So, but the big effort is going to give the vaccines, deploy vaccines in countries that do not have the resources that we have, and this requires a massive input of effort. And the World Health Assembly is going to be voting on this coming up in the summer of 2020. But there's some obstacles that we need to face. And Quebec has also been, sadly, another champion. We have been a champion of anti-vaccine activism as well, particularly against HPV. The World Health Organization has, in fact, called vaccine hesitancy among the 10 threats to global health in 2019, because of this has prevented some places actually to have good coverage of HPV vaccination. Look what happened in Japan. Japan was doing very well. It incorporated HPV vaccines right early in the program, and what you see here in blue, those who received the first dose, in red, those who received the second dose, and green, those who received the 3 doses. In other words, the green is the one that shows complete vaccination. So Japan was doing upwards of 70%, around 70% coverage, which is very good, very close to 90% that we hope to attain. And time passed, and eventually a little scandal that happened in Denmark, of all places, had nothing to do with Japan. And eventually this hit the media, and it was amplified, all of these fake news about the safety of HPV vaccine. Eventually the government withdrew support from the public vaccination program. They didn't stop the vaccination. They just say, we're not supporting that anymore because of the political pressure on the politicians. So look what happened as soon as this happened. The coverage of HPV vaccination dropped dramatically. So there's going to be an unprotected generation cohort there in Japan that's going to be unprotected against vaccines. What are we doing in Canada? We're doing quite well, in fact, quite aggressively, in fact, aggressively in the good term. I mean, putting the right resources there. Our Canadian Partnership Against Cancer, which sits there in Toronto, it's a federal office, and it's mandated and funded by Parliament, has made these bold statements here, which I'm not going to tell in detail, but it's just as strong as you saw from WHO. In fact, Canada is putting not a 90-70-90 goal. Canada is putting a 90-90-90 goal in terms of coverage from all those things. And the action has already began several months ago by this elimination of cervical cancer in Canada. There's an advisory committee by Dr. Heather Bryant, CPAC, and several subcommittees, one on vulnerable populations, First Nations, and because we have a lot of that problem in Canada, many of our women, Inuit women and the First Nations women, they are highly vulnerable to cervical cancer because they sit in distant communities that don't have screening, and they're particularly vulnerable with heavy HPV transmission in their communities because of their cultural characteristics. So there is one committee on cervical cancer treatment, another one on immunization, another one on screening, and many of us, we're being able to influence all of that to end up with an action plan and summit, which is going to be February 4th. Of 2020. And then this action plan is going to be made a politically important component. So this is what I wanted to leave with you, this strong message of optimism and a little bit of caution because there's so many hurdles ahead of us here that we need to face. So I'd like to thank you very much for your attention. I'm going to show you something here that it could be the same thing that would be for my car, for Jose, or for Lucy. And that's my car, in fact. As soon as Quebec allowed the license plates, vanity license plates, I reserved myself one of these. Thank you very much.
So I will ask Ivana Puno to come in front here. I think it's difficult to acknowledge properly someone who actually steps up like this and has the generosity to come in front of an audience and tell us about their life and what they went through with cancer. And what I told Ivana and what I mentioned also to my colleagues here is that usually the testimonies, when people come and talk about their personal lives, how they went through it, that's what usually brings all of this science home. That's what carries all of those facts that we described, what it means for a person to go through this. So I cannot say thank you enough for you to be here tonight, Ivana. We have 2 microphones. Working? Yeah,
Yes.
it's working? All right.
Hello.
So how about we start with a bit of history? Can you give us an overview of how you went through diagnostics and the diagnosis and the treatments?
Yes. So good evening. Thank you for having me tonight. So I was diagnosed. I'm actually approaching my 1 year since diagnosis anniversary. So December 17th, 2018 was the day that I was diagnosed with stage 3 cervical cancer. So very aggressive, and the treatment following happened very quickly. So the following day, I actually was already scheduled with Dr. Gilbert and with the other team members to assess what my treatment options were.
You mentioned that it was really important in your case to be persistent during the process of diagnosis, and you said that it was really important, it was key in your case and critical to listen to your body. Could you tell us a little bit about this?
Yes, so I tend to be quite a persistent person, and I think I would encourage anyone to really listen to their bodies. So obviously we need medical professionals to help us gauge what exactly is going on, I guess scientifically within, or biologically, I guess I can say, within our body. But no one lives inside your actual being except for you. So you're the only one who can really detect firsthand what is outside of the norm, and what seems to be, different compared to maybe the day prior. So what prompted me to present myself to the clinic, because it was really me who took ownership in that, I noticed some changes in my body and things that were of concern, or that I thought were of concern. So I actually called myself and I made sure that I got an appointment at the clinic. And that's what led to my diagnosis a week and a half later. So it can be very subtle, but anything that you notice that might be abnormal, I would encourage you to really present yourself and take initiative on that.
And be persistent in the process.
Yes, yes. I know I can be a little annoying sometimes during my appointments because I tend to ask a million questions, but I think it's very important in terms of coping and also just having a little bit of ownership on what's going on.
We won't go through all the details of treatment, but you mentioned just how difficult and how extensive the treatments were and challenging. And you mentioned things along the lines of that what goes through your mind when you go really aggressive treatments is, will I actually be able to live my life the same way as before, or will I have to adapt in some ways of some kind? Could you tell us a little bit about were there major or changes or adaptations that you had to take into account, or if you went back to live like you were living before? Or?
Sure. So I'm sure by looking at me, you would never guess that within the last year I actually underwent, pretty major surgery, chemotherapy, and radiotherapy treatment, all within the last 11 months. So it's been a pretty intense year, to say the least. But I'm back at work full-time. I live a very productive life. I'm back into my sports that I was playing prior to the diagnosis. And I think what really was a key factor, and actually one of my medical, one of the doctors who has been treating me throughout this period, so Dr. Luis Suhami, my radio-oncologist, what he attributed all of that to was really my capability to adapt to change. So during my treatment, I was actually asked to coach some other patients who were going through a really rough time. And it's not to undermine what I went through. It was beyond difficult. That's really, I wouldn't even use that word to describe what my body physically, mentally, psychologically has gone through in the last year. But what attributed to my success, if you want to call it success, was really my ability to adapt to change. So that's what, a medical professional has told me in the past. So it is possible. You have to be able to kind of adjust your goals, and you have to be patient with yourself as well. I had an appointment with Dr. Gilbert just yesterday, and she reminded me that I'm very impatient with myself. But, you have to just kind of be aware that the body has gone through tremendous change. So you need to be patient, you need to give it time to heal, and you hit bumps along the way, and I'm still healing. There are still a lot of things that I need to deal with, and obviously the life that I had for myself all planned out, I needed to adjust some of my goals and reassess what I want out of life, and you really realize what's important at the end of the day once you go through this type of change and trauma. So it is possible, though, to live a very full life after all of this.
It's a nice message of hope.
Yes.
You mentioned that there were a few key words and key expressions or exchange that you had with Dr. Gilbert in particular that made you change your perspective on the treatment, because those were quite challenging, I heard, right?
Yes.
Could you share a little bit of these words with us, because or with anyone here whose family is going through something similar?
Yes, so she actually doesn't know this, so I'm going to mention it today for the first time. But obviously, when you're diagnosed with such an aggressive form of this cancer, there are a whole bunch of unknowns, and that's probably the most difficult part of all of this, is that you really don't know what life will look like after treatment. So amidst all of the very difficult conversations I had to have and the difficult decisions that I had to make throughout the last year, although it can be very depressing and very scary, and hopeless oftentimes, one thing that I held on to was actually discussed during one of my consultations with Dr. Gilbert, and it was that, and this happened just it was just after New Year's 2019, excuse me. Dr. Gilbert told me I should film you today in my office because I had been crying and hadn't been sleeping. I was diagnosed right prior to the holiday season last year. She told me if I could film you right now in this moment and replay you the video a year from today, I think you would look back and just be amazed at your progress and what you're capable of. And at the time, I couldn't see it, but she was in fact right, because my 1 year since that day is fast approaching, and I look very different, and I feel very different than I did, almost 12 months ago. So.
And here you are, spreading hope. Thank you.
Thank you.
So in closing, you had a few words to say, I think, on the importance of education and actually reaching for information in many sources. You felt that there was information out there. Do you want to share something about that? Right?
Yes, well, I think along with listening to your own body, just educating yourself on, just information. I think when I was growing up, I was diagnosed at 32 years old. I'm 33 today, but I was in an age group where there was a little bit of, I'd say, a lack of information. It isn't the way it is, so obvious and so accessible. So at the time, I think I'm maybe had I educated myself a little bit more, things would have been different, but I don't really want to look at it that way because you can't really go back. But I would just encourage people to educate themselves and to listen to their bodies as well.
Well, thank you, Ivana. Ivana Puno.
Thank you.
Thanks so much for doing this.
Thank you.
Thomas, could
Yes.
I just say something? I know you thanked
Absolutely, go
Ivana,
for
but I want to thank her too, because I wasn't sure whether you would come. And I asked Joanne, our clinical nurse specialist, because it's a big deal. It takes enormous courage. And I would say 70% of people we ask would say no. So I asked Joanne, and Joanne said, oh my God, she wants to educate the public. So she will do it. So thank you very much indeed.
Okay, so I have my questions here and my dedicated microphone. The first question, let's start with something that's been, I think, on and off in the presentation. Is vaccination only for the young and only for girls? It's essentially whoever wants to answer, and if you want to add afterwards, the microphones are there.
There are two angles to this question. The public health one, the utilitarian view of vaccination, and the clinical one. So let's start with the clinical one with Dr. Gilbert, and then I'll tackle the public health one.
Okay. So it's a very important question, because initially when I remember doing a fair number of debate with, one of the debates was particularly difficult, and it was a radio interview, a radio phone-in, and so on and so forth. And women were shocked. Mothers were shocked. They said, what are you proposing my 9-year-old child to be vaccinated? But what people don't understand is the thymus, which plays a very, very important role in immunity, involutes by the time you reach puberty. So vaccination is to get your body immune to this virus while your thing is at peak. So that's the best time when you can mount the strongest immune response, and before you're exposed to it. So nobody expects you to be exposed to it at night. But after that also, much, much later, it's an economic decision if the taxpayer is paying, to do it earlier on. But very few people are exposed to all the viruses. So if I tell people, we spend so much at hairdressers, on our boots, on whatever, this is a very good investment. If the government won't spend on you, it's a fairly good investment to spend on you till fairly late. Not my age, but earlier on.
Who knows, huh? A changing lifestyle sometimes could be a good trigger for that. But there's, as you heard from Dr. Gilbert, there's the patient and patient-doctor provider, let's put it in a broad sense, not only doctor, but the healthcare provider perspective, which is one in which you understand the risks, and you're having a dialogue with your clinician that frankly looks at your perspective, specifically given your contacts, given if you have had prior exposure, if you had a lesion before, whatever that would be, versus the public health situation. So the vaccines have been approved in Canada all the way to age 45. So 45, we're talking about mid-adult age here. So, but the public vaccination, the taxpayer-supported, publicly funded vaccination, which is delivered here in Canada in schools to 9 and 10-year-olds in Quebec, in 11, 12, or 13-year-olds in other provinces, they're exclusively prophylactic, as Dr. Gilbert said. That doesn't mean that there's not protection. So a woman and a man who has already initiated sexual activity and may have been exposed to the virus, or it's unlikely that it would have been exposed to all different 9 types that are targeted by the vaccine. So there's always some measure of benefit. And this is the protection to the individual, himself or herself. But there's also the overall transmission prevention that happens also when you have a very large proportion of the population protected. And we're seeing now more and more, in fact, from the first one came from one of our studies here at McGill, more and more demonstration of protection to the partner of someone who was vaccinated. So there is an interruption of transmission, and this eventually permeates all the way to the community at large, and eventually decreases prevalence of the virus and ultimately reduces risk of disease.
So follow-up question. So this one was about whether the young people, why vaccinating only young and only girls. And the follow-up question is why stop screening women at 65? So why not after that?
Because if the natural history, it takes ages to go from pre-cancer, then go from CIN 2, 3, then invasion. And if you have had regular pap tests, and you have been, if not had a problem, and the natural history means the period it takes from the point of infection to forming a cancer is in the region of 20 years, you can very, very safely stop at the age of 65. Okay.
That's a clear answer.
Can I add an
Sure.
point to this? Some time ago I wrote an editorial on this exact point, and I wanted to have a nice motto to open it, and I opened with the 2 verses from the Beatles song, the Lennon-McCartney song, when I'm 64. You remember those two verses. Will you still feed me? Will you still love me when I'm 64? And that's one of the most debated things out there. You know, I agree with Dr. Lucie Goubert. That's what, in fact, most of the experts are saying. But the reality is that some cancers happen after the age 64. And the question is, the way the policies that she showed in one of his slides guarantee that a woman would be exit screening at age 65 only after she has a very safe history of screening before that. Otherwise, there will be continued follow-up after that.
All right, so can HPV vaccine, there's a few people asking this, can the HPV vaccine help patients who already have HPV?
It's a prophylactic vaccine. So sorry. It's a prophylactic vaccine. It's to prevent it from happening. It's not a therapeutic vaccine. We have also worked on therapeutic vaccines, and there are some good therapeutic vaccines coming along. But prevention is better than cure.
Very good answer, great answer. Are men and women affected in the same way by HPV?
Yes. Cells, different epithelium respond in a different way. Any epithelium can be affected, but it's epithelium that is changing over. That's why the squamo-columnar junction, the oropharyngeal, the tonsillar crypts, that it's wherever there's a lot of activity going on that this virus, Thomas, I thought it was like a detective story, Thomas, and you were kind, you were apologetic for you were saying it's not wanting to harm you, it just wants to replicate itself. So it's like, here's somebody apologizing for the HPV virus, but it's when tissues are changing constantly that the virus gets in. So I wanted to make one important point. So men and women are affected by this virus, but different organs are affected differently. And if you look at oropharyngeal cancers, it is about 3 times higher in men. And the reason, it can have any number of reasons, but one important reason is probably estrogen is protective to a certain extent. Because even if you make allowance for a lot of things, why do men have a significantly higher risk of oropharyngeal cancer with exactly the same virus? So both are affected, but depending on your hormones, depending on other things, certain cancers rank higher.
And hormones is one of the factors. HPV vaccination, a question. So the vaccine right now protects you only from certain strains, but not all of strains. How much risk reduction does their typically PV vaccine provide?
Well, as I think I've shown, the modern vaccine, which is now available, it protects against 9 types, 2 of which are against benign disease, such as the warts. I mean, although they're benign, but they're ugly looking, so you better get rid of them. And 7 others which protect against the carcinogenic types, which altogether protect against a little over 90% of all cervical cancers. So, there remains a certain number of types. Of the 25 carcinogenic types that are out there, the vaccine covers 7, the most important 7 by and large. And the ones that we do not prevent with vaccination right now, we have the 2, which is HPV testing. Of course, we'll be able to detect those, and we'll be able to treat the precancerous lesions, as Dr. Lucie Goubert showed in her presentation. But research is in motion. So there are, as we speak, several groups throughout the world looking at different types of vaccines that are more panvalent, more multivalent, and who knows, eventually a vaccine that would prevent all of the so-called mucosotropic types of HPV, the ones that infect the moist skin of our bodies, both oral mucosa as well as genital mucosa. So it's coming the same way that I showed you how much, so much research in the last few years. You just heard from Dr. Lucie Goubert. Also research on therapeutic vaccines, which is going strong, and eventually we're going to have a solution for that as well.
should all men be vaccinated as well?
Yeah, again, clinical, you just heard the nod from Dr. Gilbert, and here's a public health. I don't know. And the reason is not because of that. It's because, given what I know as a member of the SAGE committee of WHO, that's going to this very ambitious target of eliminating cervical cancer, we're having a vaccine shortage right now. In fact, we need 120 million doses per year to be able to tackle all of that. So vaccinating with high coverage women eventually will protect men anyway. So the question is, for as long as we have vaccination shortage, and we're going to have that for the next 5 years or so, as soon as 2020 kicks in with this ambitious plan of WHO, we're going to have to endure for 5 years a little scaling down. Not that we're going to stop boys' vaccination in Canada. We already made those commitments, and it would be very hard to scale back. But to be able to be, for sub-Saharan countries and Southeast Asian countries, all the countries in which HPV-related cancers are true, genuine, monumentous public health problem, they need the vaccines more than we do. So it's a question of debate right now, and WHO is working with the two manufacturers. There are only two manufacturers. I mentioned to you Merck and GSK. There are 20 new companies, most of them in China, producing new vaccines that are more or less like the ones that are already approved here in Canada, in the US, in most countries. But they're still a little far from the actual target and demonstration that the vaccine is efficacious. So until such time, 5 years, we're going to experience a little shortage. So there's a lot of that we worry about that at this point.
I think we need to answer to hear the clinician's point of view as well.
Yes. So Eduardo has, with his global hat and he has to take this view. As a clinician, and as a mother of a son, when I was one of the investigators during the first trial, the Gardasil, the 4-1. And as soon as I looked at the science, I knew. So I took the vaccine in a little, the lunch bags with this thing to England, because my children were in England. And I gave it to my son. And he said, "Why did you bring it from Canada?" And I said, "Because it's not available." And he said, "MOPS is trying to kill me with unlicensed medications." But he's glad he got it. But I believe we have a responsibility to the world. But currently, boys are vaccinated for diseases which has a fraction of the morbidity of HPV. So if you look at it from those terms, yes, I believe they should be.
All right, thank you.
The good news is that our boys are going to be protected anyway by achieving high rates of vaccination. Quebec was one of the first ones to, in fact, I was part of the committee here at the NSPQ that approved the boys' vaccination. I think it's very progressive, but when you wear your citizen's hat and you see a woman in Swaziland where that's the highest incidence rate of cervical cancer, there's not enough vaccines to deploy there, then, as most Canadians would think, we sort of think like a global citizen, right?
All right, thank you. Several questions converging on what are the early signs of cervical cancer? What are the early symptoms? Many people are curious about the early symptoms. Yep.
It is, that's an important question. So basically, the advantage of the cervix is it's not like pancreas. Somebody made that comment. It's not a hidden thing. So discharge that is different, and Ivana said, listen to your body, note things, whatever is different. So if there's a new kind of a discharge, if you bleed after intercourse, those are the earliest signs. By the time you get bowel and urinary symptoms, I'm afraid it's rather late. But it's the fact that if your discharge changes, if you have spotting, bleeding after intercourse, if you have spotting in between your periods, those are early signs.
Thank you. So we have questions, a lot of questions about transmissibility of the disease. People are wondering whether it's the cancer that transmits the virus or if it's the virus that's being transmitted between people. There's a lot of questions regarding whether a male partner who's carrier can give cancer to his female partner, for example.
Joe, or you want me to? Okay.
Well, I have one for Joe, next one lined up.
So this is why, and here Eduardo and I, he's my chairman, so I have to be very polite. Eduardo and I have different views about why I do not want HPV testing under 30. And the reason is because people freak out. When they get a hit HPV, they think it's the end of the world. And I have to kind of tell them, it's like bacteria in your sinus. You know, you have to really tell them, this is a very, so should I tell my partner? Did this partner bring this to me? You feel contaminated, you feel, and you have to tell them, this is literally a universal virus. And your partner may have it, everybody has it. The difference is your immunity did not work up to the par. You did not clear it. So forget about, you know, who gave it to whom, who is bringing it, who is not bringing it. So you don't have to disclose it. You don't have to think. I have had, I don't do colposcopy clinics anymore because I have so much problems with invasive cancer, so I have no time for this early prevention thing. But I've had, I used to look after girls who are before transplants, okay? They have to have a negative pap test before they can be put on the transplant list, because the moment you're immunosuppressed, this happens. And I had a little young woman who had sexual intercourse once when she was 17. She had never had an abnormal pap, never had anything. We cleared her, she gets a transplant, and because of this huge immunosuppressive on a transplant, 3 years later, she had a full-fledged cervical cancer. So what I'm saying is, the moral of the story is, this is a virus that is around a lot. You don't forget, I'm not, protection, reduce the number of partners, everything. But what I said is, if somebody manifests the disease, it's because their immunity didn't clear it. Yeah. Does that answer your question?
Yep, very well, yeah. 2 questions, snapshot for Joe. Oh, if you want to add, go for it.
Just make a mild counterpoint to that, and with respect to which test to use. And in fact, policies indicate that below age 30, you should use a pap test and not an HPV test, because the HPV test is a probability that's going to be positive and it's going to lead to this very uncomfortable dialogue between the patient and Dr. Gilbert, saying, how did I get this? And and then she's going to say, well, don't worry about it, you're cleared, your body will clear that. Replace that with a pap test, and then the woman will have a positive pap test. And then Dr. Gilbert would not need to have this uncomfortable dialogue with the patient. But still there is a problem there. And Dr. Gilbert knows that behind that positive pap test there's an HPV. It's just that she does not need to tell the patient there is an HPV there, except that she was not tested for it. So an abnormal pap test is a positive HPV test result. So this is the sort of thing that we need to demystify. So we have prevent ourselves from actually having this frank conversation, because it is really uncomfortable conversation to have. It's much better to demystify. It is the most sexually transmissible infectious agent that exists. It's comparable to bacterial infections, in fact. And you saw from Dr. Teodoro's presentation how infectious these viruses are. So it's better to demystify. And it is part of what we need to eradicate, to eliminate cervical cancer is to use something that would be way better than Pap tests are. And the other advantage is with vaccination, mind you, our girls here in Quebec began to be vaccinated in 2008. They are reaching 21 today, 22, 21, 22. So prevalence of HPV is going to be way low in them. So we don't need to worry about this excess number of HPV infections before age 30.
Very good. Joe, question for the university professor in biochemistry or the Goodman Cancer Research Center. How does HPV infect cells? It's probably worth a couple pages. Can you?
Yeah, so
I'm sure.
So for any virus to get into a cell, it has to have a receptor on the surface of the cell that it recognizes, and it attaches to that, and it uses that to burrow its way inside the cell. Every virus has its own mechanism of getting into cells, and HPV is no different. And actually, probably you saw, as I put up the sort of the family tree of HPV, and there's about 150 of these things, and they all tend to infect different types of skin. They got some that are really specific for the hand, and some are in the genital areas. And we're not even quite sure about, what is it, some of these viruses, we don't know what their receptors are. There's a whole lot of biology we haven't really figured out. But they have specificity for different cell types. And this has to do with sort of how they attach to the cells and how they get in. And then a lot of this is still a work in progress.
All right, another question for you. Can HPV lay dormant, without showing any sign, but yet be inside and be infected in a patient?
Yeah, that's a good point. So actually, it's sort of a stage that goes on. So if you remember the slide with the natural progression, if you get initially infected, there's a productive infection going on where the virus is replicating and making lots of virus particles. And after a while, it sort of stops making virus. But the DNA of the virus is still present there on something we call an episome. It's there, and it's still present. So it can be there and not making virus. And that's actually a dangerous sort of phase, because it's that viral DNA that eventually makes its way and gets integrated into the cells in the cervix. And it's that integration is really the dangerous event, and that's that the DNA then is there forever. And the cell starts to, over time, starts to make other mutations that can make those cells even more aggressive, and to eventually develop to a full-blown carcinoma, which can be extremely dangerous. So yes, it happens. It can be there, and it's sort of an important sort of later stage in the more high-grade lesions.
Good, excellent. So one last one, maybe. We have a bit of time left. What's the relationship between the risk factors, like smoking, having multiple partners, and the multiplication of the HPV virus? Do these factors contribute to the HPV multiplication and replication?
Let me give the epidemiologic thinking on this. HPV is the cause. And there are several things that change the speed with which HPV will be acquired, and then eventually from HPV acquisition, eventually all the way to the nasty things that he just described, such as integrated into the genome and all of that. So smoking. Smoking is a risk factor for cervical cancer, undeniably it is. Not that it's alone causes cervical cancer, but it does trigger the things that happen at the cervix, such as a loss of low immunity that eventually leads to persistent HPV infection and prevents a woman from clearing that infection. It also causes some of the genomic aberrations that happen downstream from an HPV infection. So all of these things contribute to that. Another one is parity. I think, I don't remember if you have one of those, parity was this. A number of pregnancies that a woman has, full-term deliveries that a woman has over a lifetime eventually also increase risk, but not alone. It has to be the HPV, because multiple pregnancies eventually are in themselves a condition that immunosuppresses the cervix so that to protect the baby. So this also helps the virus to stay there. Other risk factors such as age at first intercourse and number of sexual partners. Well, number of sexual partners is the actual thing that eventually led to acquisition of HPV infection. And low age at first intercourse is probably related, although we don't have proof of that, it's just epidemiological observation, but it seems to be pretty rigorous, is that the cervix is at its most vulnerable state when a woman is young, let's say age 14, 13, and eventually having sex at a very early, young age. You have, remember the transformation zone Dr. Lucy Gilbert said, this is more exposed to the world and eventually unprotected from acquisition of HPV infection. Hormonal changes as well affect. So all these, the speed with which these things happen, from acquisition of the virus all the way to developing the disease. But HPV is the main player in all of that.
This is a trick question that we have put into even, I have it in for medical students, I have it for residents, and sometimes even our fellows get it wrong. And it's what Dr. Franco said. The cause, there's only one cause, and that is HPV. It's a first cause, it's a second cause, the third cause. That is its etiology. Everything else is the facilitators, the enablers. So what happens is it's there, and it's how wide the door was to allow this HPV to enter. So as Dr. Franco said, this is why people feel stigmatized by having cervical cancer, because some of the very important risk factors are, as Dr. Franco said, when you start sexual activity very young, when the epithelium is so delicate, okay, and this huge influx of HPV. Then there's the high-risk male, okay, truck drivers and so on and so forth. Just masses of HPV being deposited there, multiple sexual partners. But the cause is only HPV. It is if it's overwhelming, or it can be one lone little poor HPV, and the immunity is so bad that you just couldn't halt it. But the cause is only, etiology is HPV. All the others are risk factors.
Very clear. All right. So this is all the time we have. We'll thank the forum speakers. And again, Ivana, for coming at this for her testimony. So, thanks for coming tonight. The next forum will be this spring. We'll disclose the date. It's going to be about the metabolomic syndrome, and it's linked to cancer. Please stay tuned on our website. Our website was down last day or so. We have problems with it. Should be up soon. Just stay tuned for the spring. And thank you again for coming. Please spread the word about these forums. And I'm grateful that you showed up tonight and you were part of this. Thank you very much.